As to my YouTube channel, was still under strength of material N6. I was still dealing with cantilevers, deflection, was still under deflection and slope. All right, I want us to look at this typical question, right? It says there, calculate the deflection at the free end. Obviously here, we will know that will be the total deflection there at the free end. All right. So at the end, at A, you want at the end of the cantilever shown in figure 4.37 in terms of EI. All right, we've given here, it's our figure there. This is what we have. We want to find the total deflection, so you must be wise. We have 2 points load here. All right, we have this one at the end, at the free end, which is the normal one. We have the second one here at B, whereby you know this one, since it's not at the end, it will have the additional, it will have what? A deflection of its own. Also, we will have the deflection due to point load, right? And remember, we'll have the deflection due to what? The additional deflection due to this side and due to that side. All right, we also have what? The deflection due to the point, due to the distributed load here, and also the deflection due to the free hand, due to additional free for the UDL. All right, let me just illustrate this so that you'll understand. If you have watched my previous video where I've introduced this cantilever, so you must know that we'll have the bending here. We'll have this beam will bend. Will bend like this. Will bend there. I'm showing you how this bend will be affected like this. We'll have, so this is a 60. We have that weight there. We have 60 there. You see, we have the bending. Here at B, we'll have the bending, which is 40, and also due to this. So you must check on this side, we don't have bending. Do we have bending on this side? No. So we'll only have the bending for what? From this side until going there, from here until going there. So you must check note. We'll have the bending due to the point load of what? Of 60. The deflection, we'll have the deflection here due to this. But here we'll have two deflections. Remember there, due to point load, also the additional deflection, will have the deflection that takes place this side. Also the deflection due to the what? Additional. We've talked about this, due to the additional what? The additional, due to the additional. It will have additional deflection due to the point there. All right. We have discussed about that. We've discussed about this. So let us answer this. Let's start here at 60. We only have one deflection. Let me not cancel this. As you can see, we'll only have one deflection. The beam will deflect where? From this side until there. We'll have this side. All right, so we have one deflection there. Deflection due to point. Let me see point A. Let me just say A there because it's A or 60 due to the point load there at free end. There at the free end. Point A, let me just say deflection at point A. Let's just check point A. We know we have free end. We'll have due to the free end, the deflection there at point what? A, due to the free hand. That A, we know that it's a point. What is the formula? I know will be W multiplied by length raised to the power of 3 divided by 3 ELI, moment of inertia. All right, we'll have this. So what is the point? This is a point there. It's A. You have what? We have 60 kilonewton. So this will be what? 60 times What is the length is the blue one. We'll have the sum of these two will deflect from this side, will deflect from here till there. So we have 340 plus 360. What will be that? Will be 700. So we'll say miss what? As 0.700 is the same as 0.7 divided by 3. Young modulus of elasticity, we given no. They said in terms of this. So in terms of that, so you still have multiply this by EI in terms of this. So that will be our answer in terms of that. So in terms of that, that is what actually we have here. All right, in terms of this. But anyway, you can let us punch this, only this. Let us check. We'll have this will give us will be 6,86 times 10 to the positive 3. We're still left with EI there. So with the deflection here at point A due to what? To a point load. We are done with that. It only has, we only have this side only, the deflection at that side. What about we go now to 40 kilonewtons? We'll have the deflection where the deflection from here until there. Also the deflection, you can see the beam is deflecting, it's bending. If you want to remember P on this bend, remember on there we'll have our P. Here we have A. You can see there is a bending, it's bending also here. That means it's from here until they also have the additional deflection from here, from B to there. We have additional, we also have this one. So we'll have what? 2, because it's not where at the end. We have discussed about that. So we'll have 2 deflections there at point B. Let's check now. Deflection, they are at point B. Let's get our deflection at point B, whereby the load that we've given there is 40 kilonewton. So at point B, we know the deflection at point B will be what? Will simply equal to the deflection, the additional deflection, as we have seen, plus the deflection due to what? To point load B there. So we know that. All right. So we know that the additional deflection we know is given by what? By theta multiplied by additional length. All right. So if you don't know additional length what it is, you will know what my previous video have explained. The additional length is the length from B until to A. This one, the additional length, will have our additional length. All right. So all right, so the you see theta is not, it's just theta, it's the original theta there. So let us find theta at B. I can just say B. Let me just say B there, because anyways we're focusing on this B thing, right? We took care of that there. All right, let me just have theta there. Theta for B. Theta. All right, so we know is given by the point load squared divided by 3 EI. That is the formula. So we have this, it's 40 times 10 to the power of 3. What about that length? Remember now, this is not the additional length. This is just the length. You see, I did not write additional length. I did not say additional length. So will be this length now from here going there is not the additional one, is what is 360. by 360 is same as what? Is 0.36 multiplied by 0.36. Obviously, we have our square there. We square this guy, divide by 3ei. So since you can punch this on your calculator, you'll have that. Therefore, in terms of that, we'll have these to be lay up. Your here is 2. Obvious, it must be 2 since it's a deflection ish. Must be 2 anyways. That guy there. So that is what we will have, that punching, plugging. There we'll have, that is 2. We'll have this. Remember, it's the same as here it was supposed to be 2. So you simply is like take on your calculator, punch 4 times 10 power 3 multiplied by 0.63 squared, divide by 2 like this. So obviously then at the bottom is still left with ei. So after we've punched that not, so this deflection that b, punch that, you'll have that this deflection would be 2,592 times 10 to the positive 3 divided by ei. All right, this is simply just this. So let us find the additional deflection. You know, the additional is that theta there. You know, is that deflection there, the slope multiplied by the additional length. So we can plug in, we have this guy there, 2,592 times 10 to the positive 3 divided by ei multiplied by this additional length. Here it's our additional length. You know, it's from there till there. Let me use some different, from here until there. This is our additional length is 340. So it's 0.34 additional length multiplied by 0.34. Therefore our additional deflection will be what? Additional deflection. So remember, this is under point B. We're still under point B. I've just wrote in there. So multiplying this will be multiplied there on our top part. We together there. Then when you multiply that, we'll have 881,3 divided by ei, like this. All right, we have now this. We're still under point B. We have now this guy here. Now let us check the deflection due to the point. Remember, we are working under point B. So still under point B. So what will be that now? So let me work it out here on this space. Now the deflection due to the point, obviously since I've indicated that we're dealing with point B, we'll have our W multiplied by L cubed divided by 3ei. So what will be this deflection? point. Actually, this is point what at B. We know that. So the weight, the point there is 40 times 10 to the power of 3. The length now, be carefully, is this one. This form, let me erase it here. Will be this one. Obviously 3/6, and then whereby it's the same as 0.36 cubed divided by EI. So you punch this on the calculator, you'll have there for the deflection, that will be equals to what? To 622,1 over EI. So we have this now. So we have the boat now. We've calculated this and this, so we can have the deflection at B. Actually, this is just the total. Remember, at B, it's a deflection at B. Will be that. So having the deflection at B, we'll have the sum of that two. Remember, it's in additional deflection, will be additional deflection plus the deflection due to what, to the point exact. So we have this 881,3 divided by EI plus this one we got 622,1 over EI. The mirror. All right. All right. So this is the deflection at B. We took it. We know this is a deflection, just a total deflection at B. This will be a total deflection. So the minute said B, total deflection is supposed to be now total deflection for point B. Let me just say total deflection when we add total deflection, but yeah, it's at when we're focusing at point B, deflection when we're focusing at point B. There, yeah, deflection, total deflection when we're focusing at point B. This will be our total deflection at point B. You can see total deflection at point what, B, at B there. Total deflection at point B, focusing on B. All right, focusing on that point there, B, deflection at B. So we add. So you know maths, the denominator is the same. You add the numerator, you'll have this. You simply just add there. You know maths, isn't it? So we'll have 1503 over EI. So you got this part, the deflection here. We have the deflection. We did calculate the deflection here. Also, we have the deflection here. We are done with that deflection. So my question, what now? It is left. What's left now? What is left? All right. The left part now is this. We are done with this. Now we go to what? To distributed. To this distributed load. Okay, let us go to this distributed load. Have our distributed load. So we know we'll have, remember, if you have W like that, if you'll have this due to this distributed load, also the due to the additional. we'll have additional, because it's not here, it's supposed to be from the free end like this, then we'll not have what, the additional deflection. But if it's not from the end, we'll have additional deflection due to UDL. There we had before was additional due to point load, now we'll have due to UDL. So we're focusing due to the the deflection there due to the distributed load, the deflection due to UDL. Now let us focus this one due to UDL. So what will be that? Obviously, the deflection due to UDL will have the additional deflection due to this UDL. All right, due to this UDL additional, will have the additional deflection, but due to UDL plus the UDL load, the exact one, the UDL load additional. Let me just say the due to the UDL exact, or you can say original exact one. It's the exact is for that. So for the remembrance purposes, so this UDL then, or let me just say here, total deflection, because you're under UDL, total deflection for UDL. Yeah, sound better here. I just say UDL. So we have to find these two. So how can we go about that? How can we go about that? All right. How can we go about this? So we have to the additional. We know that the additional is always will be what, the slope to the slope, where won't be just the slope, will be the slope at B, because the UDL starts where, here at B, but due to the UDL here at B, but due to the UDL, the ACT slope of what, due to the, it's a UDL slope, it's a slope of what, due to what, UDL, not the point load, UDL multiply by the additional length, All right, how can we call it? Let us find the slope so we can be good. The slope due to at B, due to what, UDL, we know due to UDL, what will be that? Due to ADL, we'll have W multiplied by L cubed divided by 6 EI. Okay, what is our W then? So our weight is UT, is not just the point, it's UDL also is the one of the UDL distributed weight there, the weight there, distributed load, uniform distributed load, we are given, yes, it's 120 kilonewtons. 120 kilonewtons. So yeah, we have 120 kilonewtons. 120 kilonewtons times 10 power of 3. Then what will be the length? Focusing for the free side is this, going there until there. No, just the slope will be original, is not, sorry, this will be, the slope cannot be additional, man. I want, this will be, yeah, additional here. I mean this length cannot be additional. I mean this length is not additional one. This length is the one from the, is the distance of that distributed load. This distributed load is distributed for which length is this? The for that length there, 360. So it is spread for 360, which is same as times 0.6 cubed. Since we have that, divide this by 6 multiplied by EI. Alright, so we'll punch this on your calculator. You will have these to be 933.1 over EI. This is what you have there. Alright. So remember, you simply calculated the slope. So we want UDL additional, will be the slope multiplied by additional length. The slope we did calculate that be, here it is 933.1 over EI multiplied by additional length. Now the additional length is from this UDL where it starts here at B, going there is 0.34 multiplies 340, the same as 0.34. So what will have, this will goes there. What will be that UDL addition, the deflection will be how much when you punch that guy there? Alright, we'll have 317.4 over EI. Alright, this is what you have now. Then what we left, we have this now, supposed to have for UDL, the exact UDL, for the UDL, not the additional. For the UDL, the exact will be W length raised to the power 4 divided by 8 EI. Right, we know this, it was 120 times 10 to the power of 3, but now this is the exact length, just the spread of the UDL. The spread of the UDL is 360, as you can see, spread for 360 there. Right, so it has spread for 360 by same as 0.36 raised to the power 4 divided by E8 multiplied by I. So you will punch this on the calculator, therefore you'll find the deflection due to UDL will be what? Due to the UDL part. Alright, will be 251.9 over EI. You got that. So let us find the total. This is the equation that we'll use. Obviously, the total one there. Remember, we are under the UDL. The total one there at the UDL, the total deflection, the way we're working at the UDL. We simply add what we got at this. Remember, will be deflection of the UDL, the additional one, plus the UDL one. So what we have the additional one, we got this 317.13 divided by that. So we'll sum up this 317.3 divided by EI plus this one is the one that we've calculated it here. It is 251.9 divided by EI. We took it, isn't it? So we add this. The denominator is the same. You add what is on the top, you know maths. So adding this, you'll have 569,2 over EI due to UDL. You have this. All right, you have this. What we have all of them now. 3 of these: UDL, point loaded A, point loaded A, B, C. So we add all of these now. The total. You take the total, all of the total. Now you add. There we have the totals. We take all of these totals now. Take all of the totals. We add all of the totals. So we'll have the total deflection here. When we add all of these, this will be total deflection at A at the end. The total deflection will add all of these totals. Now we come, since we had these totals, so we add the totals separate. So the total deflection, we're adding the total deflection, all of the deflection. So it equals to total deflection, total deflection due to UDL plus the deflection, total deflection due to the point load, due to the point there at B, plus total deflection due to the point at A free end, the point there at free end at A, at point A, at point B, C with UDL. Then we add all of these. Alright, here it's our UDL. It's 569,2 divided by EI plus, let's go to this. Let us check that total. Here it is. Also another total at A. Here it is. So we can add all of these. We're just adding now. Just adding. We took care. We are just adding the totals that we have. 1503 over EI plus this other one, the one that we add at the end, which is 569,2 over EI. Those we total. We have these 3. Now we add this is the same, is the same, is the same. So we add this. So we add that what is in the top there, we'll have 8932 over EI. So that is your deflection, total deflection. Alright, so thank you for watching. May you kindly subscribe to my channel and click the notification button so that you'll be notified whenever I post a new video.